Hello everyone, I hope you're all doing great. Today, we're going to dive deep into a highly practical DIY project. Building a 12V battery pack using 18650 lithium-ion batteries in a 3S7P configuration. Whether you're working on an electronics project, powering a small vehicle, or just want a portable power supply, understanding how to assemble your own battery pack can be incredibly useful. So let's get started. First, let's talk about the components we're going to need. We'll be using 18650 lithium-ion batteries, which are a very popular choice in DIY battery packs due to their high energy density, reliability, and availability. For this project, we will be using 21 of these batteries. In this configuration, 3.7p, the 3S part refers to the batteries being connected in series, and the 7p means that each series connection will consist of 7 batteries connected in parallel. The reason we connect batteries in series and parallel is to get both the voltage and capacity we need. By connecting 3 batteries in series, we are effectively adding their voltages together while keeping the current capacity the same. Since each 18650 cell typically has a voltage of 3.7 V, connecting 3 in series gives us a nominal voltage of 11.1 V, which is close enough to the desired 12 V. Now, when we connect 7 sets of these series in parallel, we multiply the capacity. Each 18650 cell typically has a capacity of 2500 mAh to 3000 mAh. So with 7 cells in parallel, we get around 7500 mAh to 21000 mAh, depending on the cells you are using. Now that we have an understanding of what we're building, let's talk about the tools and materials. Aside from the batteries, you will need a battery holder or spot welder, nickel strips for connecting the batteries, a soldering iron or spot welder, a battery management system, BMS board, some wires, a voltmeter, heat shrink tubing or electrical tape for insulation, and a suitable enclosure to house your completed battery pack. The BMS board is a crucial component, as it ensures that your batteries are charged and discharged safely without being overcharged or overly drained, which can significantly extend their lifespan and prevent accidents. Now that we have all the materials, let's begin the assembly. The first thing you need to do is ensure all your 18650 cells are of the same voltage and capacity. This is essential to ensure the cells charge and discharge evenly. You can use a multimeter to check the voltage of each cell. Ideally, they should all have a voltage close to 3.7 V. If some are lower, you can charge them up individually to match the others. Next, arrange your batteries in groups of 7 cells, connecting them in parallel using nickel strips. This means the positive terminals of all 7 batteries should be connected together, and likewise for the negative terminals. After soldering or welding the connections, you'll have 7 groups of parallel cells. Remember to use a soldering iron or spot welder carefully, because overheating the batteries can cause damage or even be dangerous. Spot welding is preferred over soldering, as it produces less heat and creates stronger connections. Now, we will connect these 7 parallel groups in series. This involves connecting the positive terminal of the first group to the negative terminal of the second group and so on, until all groups are connected in a chain. At this stage, you should have a pack that produces a nominal voltage of around 11.1 baht. Once your series and parallel connections are made, it's time to install the BMS board. The BMS is responsible for monitoring and balancing the cells, ensuring that they all charge evenly and that the pack doesn't overcharge or discharge too much. The BMS will have multiple connection points for each cell group, which means you'll need to connect it to each of the parallel groups, as well as to the main positive and negative terminals of your battery pack. This step is crucial because a well-functioning BMS will protect your battery pack from overcharging, overheating, and other potential hazards. Before closing everything up in a case or housing, it's vital to test your connections. Use a multimeter to check the overall voltage of the pack, ensuring it's around the expected 12 V. If the voltage is too low or too high, double check your series and parallel connections, as well as your BMS wiring. Once you've confirmed that everything is functioning correctly, it's time to insulate the pack. You can use heat shrink tubing, electrical tape, or a combination of both to protect the connections and prevent any short circuits. Once the pack is insulated and safe to handle, place it inside a suitable enclosure. The enclosure should be sturdy enough to protect the battery pack from physical damage, and it should have some ventilation to avoid heat buildup. If you're using this battery pack in a mobile application, like powering an electric and a power switch for extra safety and convenience. Don't forget to subscribe to our YouTube channel for more exciting projects and tutorials. Until next time, take care and happy building.